Welcome to FM Tuition Academy. Are you a grade 10, a grade 11, a grade 12, or somebody who is doing GCE, whether you're writing this year or next year? Today I'm going to be teaching you on practicals. This is tritration. So tritration usually comes in your exams, and tritration is not very hard. You just need to understand the principles between a base and an acid, okay? And few calculations so that you know how to do them. So they usually come in the exam. So you know that you want to do online tuitions. Comment your phone number right now. Any place you're watching me from, in Zambia, Karolushi, Ndola, Mufurila, Mongu, any place. Comment your phone number as we begin to discuss this exam question. Now, question 1. These are steps, okay? Titrate Q with P of sulfuric acid, okay? So, you look at the letter. Before you know, how can you know which one is the acid and which one is the base? Before I even continue, just by looking at this table here, sometimes they'll give you this table. You always look at the letter that is in the table. The letter that is in the table is the one that is the acid. So what letter do you notice in this table? Before I even continue reading this information, I look at the table down here. The letter is P. The letter that is in the table is always the acid. So meaning this P is the acid. Okay? So if P is the acid, meaning Q is the base. Okay? Q is the base before I even continue. Okay? Base and acid. Okay? Because the letter, if it was Q here, meaning Q would be the acid. The letter that is in the box is the one that is in this titration box. Okay, let's look at the steps. Second step, solution Q is 0.200 moles per decimeter cubed. Okay. Put Q is a base, as I said, Q is a base. Put Q in the pipette, 25 cubic centimeters, 20 cubic centimeters or 25. So it means you can either use 20 or 25. It doesn't matter. Whichever you want, you can use. Now, the results of the burette reading are, the results of the burette reading. These were the results when you did your titration. So here I'm just going to help you to understand. Now my titration, I want it to be between 18. My titration, I want it to be between 18 to 21. Okay? I've chosen that titration. Now, I'm just teaching you how to pass. These are just tricks you should know. So the titration, my numbers will range from 18 to 21. So on the initial reading, I'll put 0. Everywhere where is initial reading, I'll put 0 there. On initial reading, I'll put 0. Everywhere where is initial reading, 0. Initial reading there, 0. Initial reading here, 0. There, 0. There, 0. So this one, I'll say 18. This one, if I want, I can say 18.3. This one, I can say 19. This one I can say 20. Okay? I've just chosen numbers between 18 to 20 to 21. Any number. I think I taught you how to come with this table. So 18 minus 0. 18 minus 0 is 18 here. Oh. I mean, this is initial reading 0, 0, 0. Final reading this. So here you're supposed to tick the best titration. Is it this one? Is it this one? Is it this one? Or is it this one? Okay. Now we are going to look at question 1. We are going to look at question 1, guys. So before I tick the best titration, I'm supposed to find the average of this one plus this one plus this one and plus this one. The number I get, the one that is near that number, that's one that's going to be the best titration. So we're now solving the questions now. Please, you need to practice these things because they will come in your exam. So you need to make sure you understand what I'm trying to explain to you. So question 1 is saying, determine the average. Determine the average volume of P. The average volume of P. This is P. So what is my average volume? This one plus this one plus this one plus this one. So since I've done 4 titrations, I can do 5 if I want. I can do 6. if I want. I can do titration 1, titration 2. Here on the rough, I don't write anything. On the rough here, I've left it blank. But on first titration, second titration, third, fourth, it can be fifth, sixth. It's up to you. So you add these numbers: 18 plus 18.3, 18 plus 18.3 plus 19 plus 20 divided by, since you have done 4 titrations, 1, 2, 3, 4, you are going to divide by 4. If you did 5 titrations, you divide by 5. If you have done 6 titrations, divide by 6. It's up to you. But at least 4 is more than enough. Okay? 4 is more than enough. So you can end up on 4 there. Okay? So how do you add those? So we need to now solve that question now. We are adding those numbers. We are adding those numbers, guys. We are adding those numbers. So I'm just trying to add those numbers. That is that is 18 plus 18.3. 18 plus 18.3 plus 19 plus 20. Okay, 75.3. 75.3 divided by 4. 18.8. Okay, so my titration here is 18.8. Okay, my titration here, after doing this, the answer I get here is 18.825. I've added this plus this plus this plus this. The answer I've got, I've divided by 4 since there is no space here. So it's 18.3 cubic centimeters. Okay? Don't get confused. So the answer I've got here, it is 18.825 cubic centimeters. This is the answer, the average titration. Okay? Question 2. Question 2, guys. What is question 2 saying? We're going to look at question 2, question 2, question 2. Question 2, question 2. What is question 2 saying? Okay, I'll wrap this part. This is the answer, 18 point. We are now going on question 2, question 2, question 2, question 2, question 2. Question 2 says, that is question B. Okay. Question B is saying, calculate the number of moles of sodium hydroxide in the pipetted volume Q. Okay? In the pipetted volume Q. You remember I said Q is a base. Q is a base. So how do you find the number of moles? The number of moles of Q is very easy. The number of moles of Q is very easy. From the instructions that I gave you the formula for the number of moles. Okay? So, number of calculate the number of moles. There's a formula I gave you some time back. Concentration is equal to number of moles over volume. I think I gave you this formula some time back. So, calculate the number of moles of pipetted volume Q. So, concentration is what? You remember the concentration of Q? We read it. It was on step what? What step is it? Since I've wrapped the first step, the second step, I want you to check. Step 2. There was step 1, step 2. On step 2, the concentration was 0.02. You remember the concentration here, it is 0.200. It's there on step 2 where I grabbed. The concentration was given for Q. So the concentration you put 0.200 is equal to the number of moles you do not know. You put X. That's the one I'm finding. The volume for Q. The volume for Q. If you remember, the volume for Q is on step 3. It is written. If you look at step 3, it is written pipette Q. The volume for Q was actually what? It's in step 3. It was 25. It was 20 cubic centimeters or 25 cubic centimeters. Okay? And I said you can either use 20 or you can use 25. Okay? This concentration is on step 2. Please remember I've wrapped those steps. So step 2 you can go and check. You find that 0.200 of Q, of letter Q. And then the number of moles you don't know, that's X. The volume, that's what the volume was 20, is on step 3. Step 3, the volume is there. So I said this volume is always in what? Brackets, decimeters. So you have to convert either 20 or 25. I'll use 25. So 1 decimeter cubed is equivalent to 1000 cubic centimeters. How many decimeter cubed are equal to 25? Like you remember I said you have to convert this to decimeters. You cross multiply. 1000x is equal to 25. You divide by 1000. Also this side by 1000. Mathematicians should know how to do this, how to convert. So x is equal to 0.025 decimeter cubed. So that's the one that we use. You convert the 25 into decimeters by saying 1 decimeter cubed is equal to 1000 cubic centimeters. Then you cross multiply, it will give you 0.025. So it will give you 0.025. Okay? So on the decimeter, that's a volume. And then you over 1, you cross multiply. Okay? You cross multiply. Okay? You cross multiply. Here on the base titration, on that box, you remember here it was, here where I've wrapped here, on the box here, it was saying tick the base titration. Since my titration is 18.8, which one of these is closer to 18.8? It's 19. So meaning this is the one that I'll tick. Okay? 19. I didn't tick this on the table here. 19. Base titration will be 19. Why? Because 18.8, after 18.8, the next one is 19. You see, it's closer. So meaning my best is 19. You just pick the one that is closer to this number. Okay? So you tick the best titration there. Okay. Let's continue solving this. So you cross multiply, guys. You cross multiply. So 0.200 times 0.025. So you multiply those. You're trying to find the concentration. So when you multiply those, what do you get? That is 0.200 times 0.025. It is 0.005 moles per decimeter cubed. Why? Because it not per decimeter cubed, sorry. I mean it's moles. We're finding the number of moles. So it is 0.005 moles. It's not concentration you're finding moles. Okay? Those are the moles that you're finding. I hope you have understood. The concentration was given on step 1. The number of moles we do not know, it's X. For Q we didn't know. But they gave us the concentration for Q. This was a concentration for Q, and then this was a volume for Q. And that volume we converted from 25 centimeter cubed to decimeters by using this variation. Okay, I think you have understood. And then part C. Part C, Part C, it is saying, part C is saying using the answer in B. Okay? Using the answer in B. Okay? Using the answer in part B here. Using that answer, this one. Calculate number of moles of P. Okay? Okay? Using the answer in B, calculate the number of moles of sulfuric acid. Using the number of, calculate the number of moles of sulfuric acid using the answer in B, calculate the number of moles of sulfuric acid. Okay? So end there. This is where I'll end. And then I'll proceed.